Hello guys, my name is Liad. Today I will discuss a data structure related problem. I have taken this from Codeforces. You can see this is rated 1500. So let's see the problem. From here to here they have defined the W linked list. W linked list is one of the fundamental data structure. You can see, so we already know what is W linked list and its structure. Let's read the problem from here. In this problem, you are given n memory cells forming one or more W linked lists. Okay, each cell contains information about element from some list. Memory cells are numbered from 1 to n. So this is on based indexing. So we have one or more W linked list, and for each cell I, you are given two values Li. This is cell containing previous element for the element in the cell I, and Ri cell containing next element for the element in the cell I. So we know that in double linked list we have a previous pointer and next pointer, right? By which we can access the previous node and the next node. So in this problem we have two values, which is Li and Ri. We can go from the current element to the left element or previous element by this Li, and we can go from current element to the next element from by Ri. So if cell I contains information about the element which has no previous element, then Li equals to 0. So if the current node has no previous element, then Li will be 0. If cell I contains information about the element which has no next element, then Ri equals 0. If the current element has no next element, then Ri will be 0. This is a structure. We can see that here are three doubly linked lists. So it is 1, it is 1, and it is 1. First of all, say that L1 equals 4 and R1 equals to 7. That means that the left value of element 1 is equals 4. The left element of 1 will be 4. So you can see the left element of 1 is 4 and the right element of 1 is 7. So right element of 1 is 7. Again, left element of 2 is 5 and right element of 2 is 0. That means left element of 2 will be 5 and there is no right element of 2. In this way, linked list is created. So your task is to untie all given lists in a single list, joining them to each other in any order. In particular, if the input data already contains a single list, there is no need to perform any actions. Print the resulting list in the form of values Li, Ri. Any other action other than joining the beginning of one list to the end of another can be performed. We have to make all the W linked lists linked. Okay, so there will be one or more than one W linked list. We have to link all those W linked lists. Okay, so if there is already one W linked list, so we have to do nothing then. Let's see the constraint. There is a small constraint, right? N is in the range 100. So there will be then n lines which will contain LIRI. Now we have to print the answer, print n lines actually. Each line will be contains LIRI. That will be the left value of the node and the right value of the node after merging all the linked list. Let's try to visualize the problem that you have a bunch of linked list, right? You have one, two, three, or more than one linked list. Then you have to link those linked list. Okay, link to all the linked list in one linked list. Suppose you have a linked list in here, you have a double linked list in here, you have a linked list in here, and you have a double linked list in here. So you have to link all these linked list in such a way that if you traverse from one linked list or one node, you can traverse whole the linked list. Suppose this will be linked with this, and this will be linked with this, and this will be linked with this. Okay, if you traverse from this, you can traverse all the whole linked list, and the linked list will be also linked to the previous node, right? So because it is double linked list, so if you want to traverse from this or this or this, so you can traverse from all the linked list. Okay, so this linked list contains one or more nodes. This linked list contains one or more nodes. This linked list contains one or more nodes. We have to consider that this link will not contain loop also. So if you make the linking of this to this again, it will create a loop, and this should not happen, right? Let's see one example. Suppose let's see the first example, which is this 6417. It is 6. Okay, it is 4. then it is 1, then it is 7. Okay, they are linked with each other, so it can be good to the previous also. Again we have 3 on one node in a linked list, and we have 5 to another link in another linked list. So we have 3 and we have 5, we have 2. Okay, these are two are linked with each other, so we have to merge them, or we have to link them in such a way that this will create a single linked list or single doubly linked list, right? Okay, suppose we will traverse from a linked list, and then we will link them one by one. These will link to this, and these will link to this. Let's see the code. So here is the code. Firstly, I have taken the number of node, this is n, and then this is a left value and right value. So I have read the left and right value. So if left is 0, then I have inserted this into the left set. Then if the right is 0, then I have inserted this into the right set. So this actually stores the leftmost node, actually leftmost nodes that have no previous value, and that contains the rightmost node which contains no right value, right? Suppose there are many linked list, one linked list, two linked list, three linked list. So we have to join them, or we have to link them, right? So for that we have to maintain something that we have to confirm that there, if we link two nodes of any linked list, this is not happening in the same linked list. For that I have made a frequency array that will store the counter of which linked list the node is in. First of all, I will make a visited array. First of all, it will be false, all of them. So I will make them false by div 0. 0 means false. It will make all the values 0. Then I have traversed a loop. Okay, then if the node is not visited, then I will visit this node. I want to traverse all the node in that linked list. So which linked list? The linked list which this node is in. First of all, I will traverse from this node to the rightmost node of this linked list in this way. Current is I, then I will go to car is not equals to 0. So if the right pointer or right node contains 0, then it will break the loop. Okay, so first of all, in this loop I will make the node visited. I will store the frequency. So for that I have incremented the counter. Then again I have traversed the linked list from the current node to the leftmost node in the same way. When the left of the current node contains 0, then it will break. Then I have all the linked list separate. From this I have linked all the linked list. Okay, so for that I don't need to traverse from all the nodes, because if I traverse from one node, suppose all the test cases will contain at least one node, right? So I will traverse from node 1, then I will traverse to the right only. I will traverse to the right, and whenever I will reach the right most node, then I will link this with another linked list if there is any other linked list, right? Then I will link this node with the leftmost node of another linked list. Okay, I will go through that linked list also. Then I will make another linking from the rightmost value of that linked list with another leftmost node of another linked list. In this way I will link them. I will link them in a single linked list. It is actually right set. So if it is contains less or equal than one value, then I will break the loop, because um, whenever it will reach size 1, that means that we have uh, we have linked all the linked list in a single linked list, right? Because when the right size will be 1, whenever there is a single linked list. right? Whenever there is single linked list, there is a single leftmost node where there will be no left node, and there will be a single rightmost node where there will be no right node, right? So then their right size will be 1. So let's see the loop. If the right value of the node contains 0, then it means that I have reached the rightmost node of the current linked list, right? I will make a linking with another linked list. So for that I have to link with the leftmost node of another linked list, right? Okay, I can also make the linking with the rightmost value, but I have made it with the leftmost value. Okay, leftmost node. So for that I will get it from the left set. Then if it frequency is not equal to the frequency of the current node, that means it is in the different linked list, right? So then I will make the right node of the current node will be that node. Okay, I am dereferencing the pointer. It is actually contains pointer. Okay, then I will make the left node of this node will be the to the current node. Okay, then I will erase it from the left set. Then I will also erase the current node from the right set. Okay, if the frequency of the current node and the frequency of the another linked list is same, then I will erase that node from the left set. Then I will again store the first node of the left set into the IT pointer. There will be no more than one node that will be in the same linked list, right? Because the leftmost node will be one node for a single linked list, right? So I have erased this, so there will be no left node will be 0. Then I will make the same thing again. If I have made a linking with the current node with another node, so I will make the frequency same, right? For that I have made the right node of the current node to the equal to the frequency of the current node. Okay, then I will go to the next node or right node. So in this way I have made all the linking. Then I have painted all the left node and the right node of all the nodes. Okay. Okay, you can see that I have made the submission already. This is accepted solution. This is the same code. I have made this. Okay, so this was all for today. Till the next video drops, keep practicing. And thank you for watching.